Hello all, welcome to your first online video. We are going to start with 7.1, inverse variation. So what I'm expecting is that we're thinking of this as the whiteboard and that we're copying down notes as we go. Feel free to pause at any time. Maybe you need to catch up. Maybe you need to go ahead and just kind of make sure that you have all your notes down. So this video is for you to use as you'd like. All right, so hopefully by now you've read 7.1 and you've understood a little bit of inverse variation. And with inverse variation, we actually are going to go ahead and classify it as y equals a over x. And it's the idea that as y gets larger, x is going to get smaller, or as x gets larger, y is going to get smaller. And of course, in this situation, we know from our domain that x cannot be 0 because it is in the denominator. The other part that I want to point out about this is that a is your constant. It's what we call our constant of variation. And this means that a, of course, is a number where you're going to keep y and x as variables in your equation. So this differs a little bit from what we call direct variation. So I'm going to switch colors here. We're going to put this in blue. So direct variation is when y is equal to x, and as x gets larger, y also gets larger, or as x gets smaller, y would get smaller. And you guys kind of touched on that a little bit in your homework. Hopefully you finished up that homework that we got right before we closed. So I'm going to move on to classifying our inverse and direct variation. I'm going to move back to gray here. All right, and I'm going to move this down a little bit. So if I have something such as y times x is equal to 4, and I'm not quite sure if that's inverse or direct, or if maybe it has no relationship whatsoever. It's a little bit hard to see because x and y are on the same side. So what I'm actually going to do here is that I'm going to solve for y. So I'm going to divide both sides by x, and then I can see that y is equal to 4 over x, meaning that x is now in my denominator. I know that x cannot be 0, so I'm just going to go ahead and list that. And then I'm going to classify this as inverse variation. And the reason that I'm able to classify this as inverse variation is because I can see that as x gets larger and larger, so let's say that x is now, 95, that this is now 4 over 95, which is a very small fraction, meaning that y is equal to 4 over 95. And then I might have some other equations that we're going to use. So I might have something like y over 3 is equal to x. And again, this might look like inverse variation because we have a fraction. However, if we go ahead and we solve for y, meaning that I'm going to multiply both sides by 3, then I see that y is equal to 3x. It's a linear equation, meaning that we can go ahead and we can classify this as direct variation. So far we've had inverse variation and direct variation. And so there are also times when we might have neither inverse nor direct. And that would be something like this, where I have y plus x is equal to 4. And again, solving for y to kind of see it nice and clearly, I'm subtracting x on both sides. I get that y is equal to 4 minus x. Now this is also a linear equation. However, it has a constant attached to it, where this one, the y-intercept would be 4, the slope is -1, meaning that it's neither. So this one is neither. It neither varies directly or inversely or directly with as x and y get larger. So that's kind of classifying your inverse and direct variations. The one thing that I do want to point out about this is that as of right now, they don't have any constants with inverse and direct variation. However, that neither one does. Okay, so moving on to one more topic in 7.1, and that is the idea of writing inverse variation equations. All right, so we're going to go ahead and we are going to state that x and y are varying inversely. So what this means is that we're going ahead and we're saying, hey, this is going to be an inverse variation. So we automatically know that as x gets larger, y is going to get smaller, and vice versa. But I'm also going to go ahead and I'm going to give you x and y. So x is going to be equal to 7, and y is going to be equal to 2. Now, we know a point, the point 7, 2. However, we don't know what that constant is going to be. So we're going to go ahead and we're just going to write an equation with x and y, but leaving a as our variable. So we know that 2 is equal to some number, which we're going to use a for, over 7. And from here, you guys are all experts. You see that we need to multiply both sides by 7, meaning that 14 is equal to a. And using that piece of information, I'm now able to write my equation, which is that y is equal to 14 over x. And I'm going to go ahead and box this right here. And this is my final answer. If you'd like, you of course can state your domain, which is that x cannot be equal to 0. But we know that by looking at our equation already, we know that x right there cannot be 0. So it's not quite necessary right now, only if you wanted to add that in. So what I'm going to ask is that you go ahead and you try one on your own. So I'm going to put this in pink. I'm going to ask you to try this. So once you get your information, pause your video and try it on your own, and then come back and check your answers. So we're saying that x and y vary inversely. X is going to be equal to -4, and y is equal to -5 over 4. So why don't you go ahead, pause your video for a second, and try out this on your own. All right, hopefully you've come back and done everything on your own. You're just checking your answers. I'm going to do this one. I'm going to say that -5 over 4 is equal to some number over -4, multiplying both sides by -4, meaning that 5 is equal to a, and my equation would be y is equal to 5 over 4. So go ahead, get your notes down, and if you have any questions, either shoot me an email or you can go ahead and we have a video conference later this week.